Solving simultaneous equations by multiplying 1 with Adam Maths Tutor. In the previous video, where no multiplying was required, we said that the first step was to make sure that the coefficients of these two terms are the same. In the previous video, they were always the same, but in this case, you can see the coefficients are different. The coefficient of this term is 2, and the coefficient of this term is 1. Before using the method we used previously, we need to make sure that these are the same. We can do that by multiplying. If I multiply the second equation by 2, that will give us 8x minus 2y is equal to 40. If you keep the first one the same, now you can see that the coefficients of these two terms are the same. With this particular question, we can see that the signs are different. Therefore, we're going to have to use different signs add. 3x plus 8x is 11x. Remember from the last video, we don't have to worry about adding these together. The whole reason we do different signs add or same signs subtract is to eliminate these two terms. So that will leave us with nothing is equal to 26 plus 40, which is 66. If 11x is 66, we can divide both sides by 11, and 66 divided by 11 is 6. Now that we know what x is, we can substitute this back into one of the original equations. Remember, I always like to go for the one which has a positive in front of the term that you're trying to find. This will make it easier to solve. So substituting x equals 6 into this first equation, we've got 3 lots of x, 3 lots of 6 is 18, plus 2y is equal to 26. Subtract 18 from both sides, 2y is equal to 8. And then divide by 2 on both sides, so y would be equal to 4. And our final answer, x equals 6, y equals 4. The intermediate question has a slight increase in difficulty, but the method remains the same. This time, we'll be able to change y into 2y quite easily by multiplying the first equation by 2. 6x plus 2y is equal to 30, and the second equation will stay the same as that's already 2y. Looking at the signs in front of the terms we're trying to find, you can see that they're the same, so therefore we'll use same sign subtract with these equations. 6x take away 5x is x, and 30 take away 24 is 6. We know that x is 6. It doesn't matter which equation we substitute into, as both of the originals have a plus in front of the y terms. So I'm just going to go with the second one. 5 lots of x, or 5 lots of 6 is 30, plus 2y is equal to 24. We can subtract 30 from both sides. It's going to leave us with a negative number. 24 take away 30 is negative 6. And lastly, we can divide by 2 on both sides, so we end up with y is equal to negative 3. So solution, x equals 6 and y is negative 3. The advanced question is one of the trickiest questions that we're going to find on this topic. We can multiply the second equation by 3 to get 12x minus 3y is equal to 39. We can see that again, the signs are the same, so this time we'll use same signs subtract. This time the equation at the bottom has numbers that are larger, so I'm going to start with 12x and take away 2x, which is 10x. It doesn't matter which equation you subtract from the other, just as long as you stay consistent all the way through. So if I'm going to do 12x take away 2x, I can't then switch round and do 4 take away 39. I'll have to stay with the bottom one and do 39 subtract 4, which is 35. We can see why this one's a little bit harder now. If 10x is 35, then x would be equal to 3.5. It's perfectly reasonable to get fractional answers from simultaneous equations, but they do tend to be key ones like 0.5 or 0.25, for example. Normally, I would encourage you to substitute this back into one of the signs that was positive, but in this case, we don't have the luxury or the benefit of that. So I'm going to substitute it into the second equation, but it really doesn't matter which one you pick here. So we've got 4 lots of x, 4 lots of 3.5 is 14. And 14 minus y is equal to 13. I can solve this by thinking about what I need to take away from 14 to get to 13, or by balancing equations, I can subtract 14 from both sides to give me negative y equals negative 1, and therefore y must be equal to 1. So the final solution, x is equal to 3.5 and y is equal to 1. Before you head off, have a little look at the solution that I've done for a question similar to the intermediate one. I may have made some mistakes. See if you can pause the video, identify the mistakes, and comment what they are or some corrections below. Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with maths or finding topics difficult, you can subscribe and turn on notifications to receive regular updates about new video tutorials. Don't forget to visit my website adamonlinetutoring.com for a full searchable list of all topics with exams, questions and solutions. You can also visit me on social media using the handle @AdamMathsTutor on Instagram, TikTok, Facebook and Twitter. All links in the description below.